Okay, let's solve another sample problem. We have here, all members of the steel truss have the same cross-sectional area. If the truss is stress-free at 10 degrees Celsius, determine the stresses in members or in the members at 90 degrees Celsius. Alpha is equivalent to 11.7 times 10 raised to negative 6 per degree Celsius, and E is equivalent to 200 gigapascal or 200,000 megapascal. So this is our given figure. So the first one, para ma-solve to, let's draw first the free body diagram of the given system. So let's consider node D. So yung mga force na mag-apply doon, meron tayong tatlo. The axial load carried by each members. So assume natin tensile force yung mag-act sa bawat member natin. Assumption lang po yun. So this is force in member BD. This is force in member CD. And this is force in member AD. Naka-incline po yung dalawang bar, AD and CD, at 30 degrees. So, ibig sabihin, with respect to this axis, this is also 30 degrees. Ito rin ay 30 degrees. So, that will be our free body diagram. So, pag meron tayong free body diagram, we can now use summation of forces since meron na tayong concurrent force. Okay, so taking summation of forces along x or horizontal direction equivalent to 0, to the right forces are positive. Yung PCD, merong x component, papunta doon, positive. That is PCD. That is cosine of 30 degrees. PBD, walang x component, PAD, papunta doon, that is minus. PAD, cosine of 30 degrees equivalent to 0. So cancel to, cancel John. We can say that the axial load in member CD is equivalent to the axial load in member AD. Next one, take summation of forces along vertical axis Y. Assume upward forces are positive. So we have PBD and then plus PCD sine 30 degrees plus PAD sine of 30 degrees also equivalent to 0. But PCD is equivalent to PAD. So ito magiging PAD sine 30 plus PAD sine 30. Magiging dalawa yun. So transpose lang po natin. That will become PBD equivalent to negative 2 PAD sine of 30 degrees. And then, simplifying, ang sine of 30 degrees is 1/2. So 1/2 multiplied by 2 is 1. So cancelled na to. 1 yun. Therefore, PBD is equivalent to negative of PAD. And that is also equivalent to negative PCD. Since ang PAD ay equivalent daw kay PCD. Okay, so meron na tayong relationship ng forces. But, sabi dun sa kanina, the cross-sectional areas are the same for each member. So, pag parehas mismo yung area, multiply natin to by A, or divide natin to by A, divided by A, divided by A, we can say that the stress in BD is also equivalent to negative stress in member AD was equivalent to the negative value of the stress in member CD. So that will be the relationship for the stresses, since stress mismo yung ating kinukuha. Okay, so we have an equation there. So let this be our equation number 1. So saan natin kukunin yung isa? Hindi tayo po pwedeng mag-moment dahil concurrent force tayo. Hindi po tayo mag-moment doon. Pag mag-moment naman tayo, considering the free body diagram of the whole system, mas dadami yung unknown since may mga reactions tayo doon. So saan natin kukunin yung pangalawang equation? Kukunin natin yung pangalawang equation using the compatibility equation for the deformation of the given system. So kailangan natin i-analyze yung or kung paano madedeform yung ating system. Okay. Since stress-free pag ganyan daw, so may bigat yung mga load natin o may mga forces dyan, tension yung ating in-assume. So kapag sinabi natin tension, yung nag-act doon, magkakaroon tayo ng elongation. And then, one more thing, yung ating temperature ay tumaas, uminit. So kapag umiinit mismo yung temperature natin, nagkakaroon tayo ng thermal stress. Kakaroon tayo ng thermal expansion. So, hahaba din yung ating members of the steel truss. So, if this is the initial position of point B, yung BD natin mag-expand. So, bababa. If this is, yun na mismo yung deformation niya. Yung movement niya parehas na din since yung pagbaba natin tsaka yung deformation parehas lang yung kanyang axis. Ito lang yung medyo tricky. Yung naka-slant na dalawa kung paano natin may drawing yung ating deformation doon. So first one, yung member CD muna. Mag-expand po tayo doon. Ito yung CD, mag-expand. That will be the deformation. And then, magkakaroon tayo ng movement doon. Ang movement is always perpendicular to the axis of the length of the bar or the axis of the deformation of the bar. So, ito yung deformation. So, yung movement, perpendicular daw, 90 degrees. And then, ito yung AD, kakaroon tayo ng elongation ulit doon. And then, yung movement is perpendicular to the axis of the deformation. So, this is deformation of member CD, the deformation of member AD, this is the deformation of member BD. So, this is kanina, in respect to this axis, ito ay 30 degrees. So, ibig sabihin, ito ay 60, ito ay 60 degrees. Mapapansin natin. Okay, so simplifying, i-relate natin mismo yung mga deformations natin. Using this right triangle, palakihan lang natin. This is deformation of AD, deformation of BD. This is 60 degrees. So, since that is a right triangle, we can use trigonometric functions para ma-relate yung ating deformations. So, we can say that this is hypotenuse, this is adjacent side. Therefore, deformation of AD is equivalent to the deformation of BD cosine of 60 degrees. And that will be the relationship of the deformation. But deformation is PL over AE for the axial load. May deformation din tayo with respect to the thermal due to the temperature. Magkakaroon tayo ng thermal expansion doon. So, dalawa yung deformation na i-consider natin. Deformation of AD is equivalent to the deformation of AD with respect to the temperature plus the deformation of AD with respect to the axial load na kinikerry niya. equivalent to quantity, deformation of member BD with respect to the actual load, plus the deformation of member BD with respect to the change in temperature multiplied by cosine of 60 degrees. Cosine of 60 is 1/2 or 0.5. So simplifying, substitute lang natin lahat. The deformation with respect to the change in temperature is, ang formula natin doon, that is alpha, change in temperature multiplied by length. So alpha is equivalent to, substitute natin, 11.7 times 10 raised to negative 6 per degree Celsius multiplied by the change in temperature. The change in temperature is final minus initial. Ang final temperature natin ay equivalent sa 90 degrees Celsius minus initial is 10 degrees Celsius multiplied by the length. The length of AD is 3 meters. So gawin natin silang mm para consistent yung units natin. So 3,000 millimeters plus the deformation of AD with respect to the actual load it carries, that is PL over AE. So the load of AD is unknown. So yung ating deformation doon, PL over AE, yung P over A, that is also stress. Pwede natin gawing stress L over E. So since AD yung kinakonsider natin, the stress in member AD multiplied by the length of AD, what again? That is 3 meters. That is 3,000 millimeters over E, 200,000 megapascal Newton per mm squared. Okay. And then, equivalent to cosine of 60, gawin na natin 0.5 yon multiplied by the deformation of member BD with respect to the load or actual load it carries, that is stress L over E, that is stress in BD, but stress in BD is negative stress of AD. Negative stress of AD multiplied by the length of BD. Nasaan yung BD natin? Ito. Ano yung length ng BD natin? So, wala pa tayo dun. So, this is 30 degrees. Opposite. Ito ay hypotenuse. So, this is 3. The length is 3 sine of 30 degrees. That is equivalent to 1.5. So, the length of BD is 1.5 meters. Make it millimeters. 1,500 millimeters over E, 200,000 Newton per mm squared or megapascal. So, plus the deformation of member BD with respect to the change in temperature, that is, with respect to temperature, that is alpha, change in temperature multiplied by the original length. What is alpha? 11.7 times 10 raised to negative 6 per degree Celsius. That change in temperature is 90 degrees Celsius minus 10 degrees Celsius multiplied by the length of BD, 1,500 millimeters. So kung papansin sa ating equation, medyo mahaba lang, iisa lang po yung unknown, the stress in AD. So makukuha na po natin yan. So kapag ikakalculate natin yan, simplifying further, we can get a value of the stress in member AD, negative 112.3 megapascal, or that is 112.3 megapascal that is in compression. then that will be our stress. Ibig sabihin, yung AD kanina, mali yung ating assumption. Dapat compressive force daw yun. So since ang member or stress in AD, or since yung ating force or actual load in member CD is equivalent to the actual load in member AD, yung ating stress in CD is also equivalent to 112.3 megapascal. So our stress of member BD, using this relationship, stress in member BD is negative stress of member AD. So negative stress of member AD, negative 112.3 megapascal. That is positive 112.3 megapascal. Since positive yung nakuha nating sagot, tama yung assumption natin doon that it is a tensile stress. And that will be the requirements for this given problem.